Okay, so in our last class, we looked at logarithm. We saw how to convert uh, indices to logarithm and how to convert logarithm to indices. So we have been on this series for this is the second week. Last week we looked at the laws of indices. We saw the different laws of indices. And then on Saturday last week, we looked at how to solve indicial equations that involve indices. Okay, so you can go check the replay of that live class on my YouTube channel. So you can find that on my YouTube channel. You go to the playlist and then you locate the playlist on indices. So this week we are focusing on logarithm. But on Wednesday, we looked at how to convert good afternoon or good evening from my end is good evening. X Dreams, you're welcome. So we looked at how to convert indices to logarithm and how to convert logarithm to indices. Okay, so you can also go to my YouTube channel to look at that. So today we are going further. So today we are looking at the different laws of logarithm, the laws that govern logarithm. The first law is the addition. So just as we have laws governing indices, we also have laws governing logarithm. So but the addition law for logarithm states that when you are adding two logarithms with the same base, all you need to do is multiply the ordinary numbers. Okay? So this law states that when you are adding two logarithms with the same base, so the base must be the same. When you are adding two logarithms with the same base, all you have to do is multiply the ordinary numbers. All you have to do is multiply the ordinary numbers. Okay? So that means if we have something like this, log x base b plus log y base b, log x base b plus log y base b. So over here, the ordinary number is x. Over here, the ordinary number is y. But if you look at the base, both bases are the same. The base here is b, the base here is b. So since we are adding two logarithms with the same base, all we need to do is multiply the ordinary numbers. So this will give us log x multiplied by y base b. Okay? So this is one of the rules we need to follow when working with logarithms. So log x multiplied by y base b is the result of adding these two logarithms that have the same base. So we're going to look at an example. We'll just leave the So let's look at some examples. Before we look at some examples, let's rewrite what we had at the bottom. Okay. So this means if you are given question in this situation, you can convert it this way. But there are also some situations where the questions come in this form, and for you to solve the problem, you have to convert it this way. So you must always be careful to check, do I need to move from this form to this form, or do I need to move from this form to this form in the process of solving the question that I'm expected to solve? Okay, so we're going to look at a situation where we have this, and also we're going to look at a situation where we have this. Okay, because you can move this way, you can move this way. Let's look at the first example. We have log 2 base 10 plus log 3 base 10. So in this particular situation, what we have looks like this: log x base b, log 2 base 10. log y base b, log 3 base 10. So it looks like this. So we can move it to become like this. Okay? So this will be log, when you are adding two logarithms, you multiply the ordinary numbers. Here the ordinary number is 2, here the ordinary number is 3. So you are multiplying them together. So you're going to have 2 times 3 is 10. So this will give us correct log 6 base 10. So in this situation, we have moved from this way to this way. This is what we have here, but we simplified further to get log 6 base 10. So let's look at it. So we have, in this particular example, we move from this way to this way, right? Okay. However, in another situation, if we have log 3 into 9 times 27, log 3 into 9 times 27. So this is in this form. Our b here is 3, our x here is 9, and our y here is 27. So we can move it to become this way by separating them, right? So this can become, or this will become log 9 base 3 plus log 27 base 3 as an example. Okay? So whenever you're solving a question like this, you should ask yourself, am I flowing this way or I am flowing this way? Am I going to this way or I'm going to this way? Okay, so we go to the next law. I am hoping that we'll be able to finish all of them today so that we can look at some questions that we'll solve. So can we continue? Yes, we can. So subtraction law, when you are subtracting a logarithm from another logarithm with both having the same base, then you need to divide the first ordinary number by the second ordinary number. When you are subtracting one logarithm from another with the same base, then you need to divide the first ordinary number by the second. Okay, so if you have log x base b minus log y base b, then this will be log x divided by y base b. So here too, you can have it in this situation, or you can have a question in this situation. So while in the process of solving questions on logarithm, you might decide to move from this situation to this situation, or from this situation to this situation. Hello, Ojo. Nice to see you. Welcome. So let's look at an example. If you have log 30 base 3 minus log 6 base 3. So if you have log 30 base 3 minus log 6 base 3, this is in this situation. You can convert it to this situation. May, you're welcome. Okay, so you can have it as log 30 divided by 6 base 3, which will give us, I don't know if you can have it here, log 5 base 3. So we've looked at the second law. So we've seen how to move from this point to this point. In some situations, you might need to move from this point to this point. Let's look at such a situation. So let's say we have log 12 over 4 base 10. Log 12 over 4 base 10. So log 12 over 4 base 10 can be separated. You can split this to become log 12 base 10 minus log 4 base 10. So this will come in handy when you begin to solve questions that involve simplifying logarithms and also solving logarithmic equations. Let's look at the third law of logarithm. So we are looking at the power law. The next law is the power law. Okay. So this states that when the logarithm of a number is raised to a power, then that logarithm is equal to the power multiplied by that logarithm. Okay. Okay. So when a logarithm of a number at a particular base is raised to a given power, then this is equal to the power multiplied by the logarithm of the number at that base. So what does this mean? If I have log x to the power of m, let's use m, at base b, so this is equal to m multiplied by log x base b. Or we can write it at m log x base b. This will come in handy as we go forward. When you have this situation, log x base b to the power of m, then you simply move this m this way, and then it multiplies this logarithm. Okay, let's continue. So that means if we have, for example, log 3 to the power of 2 base 10, this is the same thing as 2 multiplied by log 3 base 10. Or we can write it as 2 log 3 base 10. This arrangement can be rewritten as this. So that means there might be some situations you might have it in this form, and in the process of solving, you might need to make it to be this form. And there are some situations where you might have it in this form, and you might need to make it in this form in order to solve the question. The zero law. The zero law. So this states that the logarithm of 1 to any base is equal to 0. So when the ordinary number is 1, then the logarithm at any base is equal to 0. So once the ordinary number is 1, then that entire logarithm is equal to 0. So if I have log 1 base 10, this is equal to 0. This is because from what we learned from Wednesday's class, if you decide to convert this logarithm to indices, and then remember, when you want to convert logarithm to indices, you have to move this base to the right side. So this will become 1 is equal to 10 to the power of 0. And we know that any number to the power of 0 is equal to 1. So 1 is equal to 1. So that proves that the logarithm of 1 to any particular base, no matter what the base is, the base can be 2, the base can be 3, the base can be 10, the base can be anything. But once the ordinary number is 1, then this logarithm is equal to 0. Does anybody disagree with what I've just done? Or do we all agree? So I said when the ordinary number is 1, this number here, so if I have log x to the power of b, this number is what we call the ordinary number. And then this is the base. B is the base, right? So when the ordinary number is 1, then the logarithm at any base, so no matter what b is, once x is equal to 1, then this logarithm is equal to 0. And we confirm that by converting this logarithm to indices. We learned that in our last class, how to convert logarithm to indices. And when we did that, all we needed to do was to move the 10 across the equal to sign. So the 10 came over here, and then we have 1 is equal to 10 to the power of, this 0 now becomes a power, 10 to the power of 0. And we know that any number to the power of 0 is equal to 1. So that means 1 is equal to 1. So most textbooks will not explain it in this form, but I normally write it like this so that a student can remember what was said. So with this explanation, you can, when you go back to the calculation, you might be able to remember what you're supposed to do. So this means when you have log 1 over x to the power of b, for example, this is equal to minus log x to the power of b. Our understanding of indices will help us here. Our understanding of indices will help us here. Remember, in indices, 1 over x is the same thing as x to the power of minus 1. The 4 is confusing. I think the 4 is quite easy. The 4 can only be confusing if you have not learned about the laws of indices. Just as you have it here, this number 5 will be confusing if you've not gone through the laws of indices. That's why when I was deciding what we are going to learn, I decided that we're going to learn indices and logarithm together. Because for you to understand logarithm very well, you should have understood indices. In this particular situation, the laws of indices is playing out. When you have 1 all over x, 1 all over a base means 1 over a number means that number to the power of minus 1 from what we learned in indices. So 1 over x is the same thing as x to the power of minus 1, because this minus 1 tells you that it is the inverse of this value here. That's what we learned in indices. So now, when you now go back to the third law of logarithm, the exponent here is negative. Okay, let me clean this off and then show you how it flows. So I'm going to write this log 1 over x. Okay, so let's see how we ended up here. Okay, let's see how we move from here to here. Let's see it. So first of all, applying the laws of indices, when you have 1 all over a value, this is equal to, so 1 over x is equal to x to the power of minus 1 from laws of indices. So we can replace this with log x to the power of minus 1 base b. Do we agree? From laws of indices, this is the same thing as this. Good. Now let's go to the third law of logarithm. The third law of logarithm, the power law. The power law says that when the logarithm has an exponent, all we need to do is multiply that logarithm by the exponent. So that means we need to move this over here. And this will give us minus 1 times log x base b. That's why I said the understanding of the first 3 laws will help us out in understanding the remaining laws. So we've moved this exponent to the front. Now, 1 multiplied by anything is that thing. So this is minus 1 multiplied by anything would be that thing. So we have minus log x base b. So that's how we move from here to here. Okay, let's continue. Okay, let's look at an example. Log 1 over 3 base 10. Log 3 base 10. So this will be log 3 to the power of minus 1 is 10. And also this will be minus 1 times log 3 base 10, which is minus log base 3 base 10. So with this, we go to the sixth law. Okay, so this states that when the ordinary number and the base are equal, then the logarithm is equal to 1. So when you have log x base x, this is equal to 1. When you have log x base x, this is equal to 1. For example, if you have log 10 base 10, this is equal to 1. How do we know? If you convert this logarithm to indices by moving this 10 over this way, we're going to have 10 is equal to 10 to the power of 1. And we know that anything to the power of 1 is that thing. So we can simply say 10 is equal to 10. So that shows that this law is correct. When the ordinary number and the base are equal, then the logarithm is equal to 1. I have one more law to look at. So what this means is that if you have log b square root of x, any root actually, it can be square root, it can be cube root, it can be any root. So this will be equal to log x to the power of 1 over n base b, which therefore will be 1 over n log x base b. So if you have any logarithm in this form, log root of x, it can be square root, it can be cube root, it can be any root. So this represents from the laws of indices. So this is the numerator is a power and the denominator is a root from laws of indices. So this is something as this. So then you move this across and it becomes that. Okay, let's continue. Example. Sorry, I made a mistake. This subtraction, sorry. So log 45 base 5 minus log 9 base 5. So what law do you think we can apply here? What law, from all the laws we've learned, what law do you think we can apply here to start off the process of solving? Does anyone know? The first law? The first law is the law of addition. Do we apply the first law here? The second law. The second law is the law of subtraction. Okay. So in that law, we are told that when you are subtracting one logarithm from another logarithm, then you divide the first ordinary number by the second. So this will be log 45 log 45 over 9 base 5. So what's 45 divided by 9? 5. So now we have log 5 base 5. So is this our final answer or can we go further? And which law is going to help us go further? Law of unity, good. So when the ordinary number is equal to the base, this means your answer is equal to 1. So since the ordinary number and the base are equal, so we can say our answer is equal to 1. Correct. So we can see that by knowing the simple laws, each of the laws, we know when to apply them in solving more complex questions as we are going to be seeing them. Okay, so can we continue? No, the answer will be 1. When the log of the ordinary number is equal to the base, everything about it is equal to 1. Right? Everything about it is equal to 1. Let's look at another question. So looking at this, the first thing we need to do, who knows what we should do first? Let's look at it. So somebody might decide to go this way by doing log 24 base 6 plus, and then the person might decide to move this 2 over here to become 2 log 3 base 6. By doing this, this might not give us any headway. So if you do this, yeah, I think you just went ahead to say what I was trying to explain. If you do this, you might not have any headway. But instead of doing that, you can just say 3 to the power of 2 is equal to 9. So you can write this as log 24 base 6 plus log 9 base 6. So doing it this way might not, what else will you do at this point? Are you going to have any headway? Because you cannot convert this to become 3. Because 3 multiplying itself will not give you 24. So there's no need moving this route. Okay. Instead, we move this way, and now we can apply the addition law. So log 24 times 9 base 6. So what's 24 times 9? What's 24 times 9? Okay, 216. So we have log 216 base 6. Log 216 base 6. So now, since we have a base 6, and we know that when the ordinary number and the base are the same, we can have it equal to 1. The first thing we need to think of is, is it possible for us to multiply 6 by itself and get 216? Let's check. Can 6 multiply itself to give us 216? And how many times will it do so? 6 times 6 times 6, what will you get? 3 times, okay, 3 times, because 6 times 6 will give you 36. 36 times 6 will give you 216. So this will give us log 6 to the power of 3 base 6. So let me wipe this off. So continuing, we need to move this 3 this way. So now we have 3 log 6 base 6. Then we can now apply the unity law. Since we have 6 base 6, this is equal to 1. So we have 3 times 1, which is equal to 3. That becomes our answer. Okay, so let's continue. So I'm going to write this down and then give you guys about 5 minutes to attempt it before I solve. Okay. Thank you, Ella. Thank you so much. So I'd like you guys to try this out in about 5 minutes. Let's see the correct answer to this. So as I said, all you need to do is apply the laws. Apply the laws we've learned today. So between these two, there is a law of subtraction. So let's work on that first. So this will give us log 12 divided by 36 is 4 plus log 192 is 4. Do we agree? Okay, someone said that. Marky said the answer is 64, okay? So if we do 12 divided by 36, we have log 1 over 3 is 4 plus log 192 is 4. So now we have plus. So we can now work on the addition law. So this will give us log 1 over 3 times 192. And remember, 192 is the same thing as 192 over 1. base 4. Next, log 1 times 192 will give us 192. 3 times 1 will give us 3 base 4. So what is 192 divided by 3? 192 divided by 3 will give us 64, I guess. Who confirms that? 192 divided by 3, is it 64? 64. Good. So we have log 64 base 4. Good. But 64 is the same thing as 4 to the power of 3. 64 is the same thing as 4 to the power of 3. So we're going to have log 4 to the power of 3 base 4. So let's write this once. So if we move this 3 this way, we're going to have 3 log 4 base 4. And we know that this will turn to 1. So our final answer will be 3. So you guys did a good job. The most important thing is attempting the question and learning from your mistake. Attempting the question and learning from your mistake. Congratulations to everyone who attempted it. Yeah, when you are doing board maths, multiplication and division are at the same level. Addition and subtraction are at the same level. So when you are moving from left to right, the one you meet first, that's the one you will work on. So if you are having a question where there's multiplication and division, if you are moving from left to right, whichever one you meet first will be the one you work on first. Here, we have subtraction and addition. They are both at the same level. So if you have a question, applying board maths, if you have a question where there is addition and subtraction, while moving from left to right, the one you will meet first, that's the one you work on first. Okay? So yes, board maths applies here. But if you start with here, you are wrong because you need to move from left to right. Okay, let's look at the last question for today. Yeah, sorry, don't write it yet. Yeah. Can you guys attempt this question? 3 minutes. Let's see how many persons can solve this question in 3 minutes. Okay, so let's look at the answer. So now, considering this, on the left side, we are going to apply the addition law. So these are two logarithms with the same base. These are two logarithms with the same base. So you are going to multiply the ordinary numbers. So this will be log x plus 2 multiplied by 3. I'm supposed to put the 3 in front, but to confirm that it is the second logarithm, that's why I'm putting it behind. It's equal to log 2 to 27. Okay, so 3 is going to multiply x, 3 is going to multiply 2. So we have log 3x plus 6 log 27. Okay, so why I included this, correct? You're correct. So why I included this is if you have 2 times 4 is equal to 2 times a, for example. If you want to get the value of a, you can just simply cancel out 2 from both sides. And you can say 4 is equal to a, or a is equal to 4. So because 2 is on both sides, you can cancel it out. The same thing happens here. Log base 2, log base 2. It appears on both sides of the equation. So you can cancel out. So you now have 3x plus 6 is equal to 27. So I included this example so that you see that. So when log of a base appears on both sides, it can be cancelled out. Good. So now you can solve it as a simple equation, although we've not learned about equation on our WhatsApp group, but let's just solve. So this will give us 3x. You move plus 6 to the right, it's going to be minus, so we have 27 minus 6. 3x is equal to 21. So if you divide, both sides by 3, x is equal to 7. So that becomes our answer. If you want to confirm that, if you put 7 here, you're going to have 7 plus 2, that gives you 9. 9 times 3, that will give you 27. So that confirms that your answer is correct. So that brings us to the end of today's class. Well done, everyone. Many of you stayed from the beginning of the class till the end. I really appreciate your presence. It should not bother you. The most important thing is the effort. So what you do is try to go through the video again on my YouTube channel. Just probably maybe during the live session you were in a hurry, but if you take your time to go through it again, by tomorrow I'll post this live class, the edited version of it. I'm going to post it on my YouTube channel. So you can watch it again, and then if you're part of my WhatsApp group, you can look for more questions and then attempt them. The ones you cannot solve, you can put it on the WhatsApp group, and other students can work with you to help you solve it. So right now, one of our WhatsApp groups, which is the interactive class, is almost 500 students. So once it is up to 500 students, we are going to close. We are not going to admit more students into that group because it's going to be very rowdy. So we'll open another interactive class or another set of students. Yeah, that's it's painful because you are a serious student. For some students, it's not painful because they don't care. So, and that's one of the signs that you will do well. Okay, to join the WhatsApp group, just send me a DM at the end of the live class. Send me a DM. When you send me a DM, I'll send you my WhatsApp number so you can contact me, and then I'll add you to the WhatsApp group. But please, I will appreciate you guys if you guys support my YouTube channel by going to my bio and clicking on the link to subscribe to my YouTube channel. Or you can just go and search for it on YouTube, Agbanimas Academy. The same name I have on TikTok. Do you teach history also? Wow, I don't. And it will be difficult to teach history online because different countries have different histories and different countries focus on different areas of history. As I said, to join the WhatsApp group, send me a DM at the end of the live class. Just send me a DM. Please subscribe to my YouTube channel. Follow me on Facebook. I'm not on Instagram, so follow me on Facebook, please. Assignment. 1 minute, 1 minute, 1 minute, 1 minute. I think I have. Let's see if I have some questions. What I would have given as an assignment includes quadratic equation, but those that can solve quadratic equations can attempt it. So I'm going to drop the last one, which includes quadratic equation for those who can solve it. Okay. Solving. So this question is not compulsory. This one is not compulsory, except you can solve quadratic equations. Okay, so that should be all for today. Thank you guys for being with me from the beginning, from the middle, from almost the end, from whatever time you joined. Okay, I'll be expecting it. So from whatever time you joined, thank you so much for being there till the end. Have a wonderful evening, guys. See you tomorrow. See you tomorrow. Adios.